2, and 1. And we are live. Good morning, Micheal. Good evening, Micheal. And good day, everyone.
Good day, Hugo, and thank you very much for accepting me in this live stream.
It is such a pleasure, and I'd love to welcome everyone who's joining. If you could introduce yourself in the chat on YouTube, why you're interested in Dask and/or Coiled and/or transforming terabytes of healthcare data with Dask, that would be fantastic. I'm of course grateful for all the guests that join us here, particularly Micheal today, because correct me if I'm wrong, but you are in Paris and it is very late for you.
Yeah, yes. To be honest, it's quite late at the moment. It's yes, it's dark outside. I confirm, but it's a real pleasure to participate and to give some information about the project I worked on with Dask. So I don't. I'm fine, definitely.
Fantastic. And I'm interested where people are tuning in from, because as people probably know, I'm in Sydney, Australia. So it's 7:30 a.m. for me on Friday. You're in Paris. A lot of people tend to join from North America and that particular time zone. So we'll see where people are coming from. But before we jump in, I thought perhaps you could give me, or you could let us know how you discovered Dask and how you decided to adopt it. I'm sorry, actually, before that, maybe you could just tell us a bit about yourself and then we'll jump into Dask.
Yes, very quickly. So thank you, Hugo. I'm a tech engineer, cloud architect, and I propose my services to companies about offering a data platform on the cloud. So I'm Micheal Sebbah, mainly based in Paris. I had some experience in London as well, and I discovered Dask 2 years ago for one of my customers who needed to transform terabytes of data, a large amount of data. He used a data warehouse for that. It was a Redshift at that moment. He was not very happy with this solution, and in the team, people code in Python. So Dask was a very good candidate.
Great. And so, in terms of adoption of Dask, how do you make the decision to adopt a new technology like Dask? What are the pros and cons? And maybe that's where you're going. So sorry for cutting you off.
No. To be honest, I'm a tech, so I like to play with new tools, to discover new tools. I usually I am interested by tools other people have already played with, to be honest. So Dask was recommended by one of my friend, and Dask was natively in Python, was natively developed in Python, contrary to Spark. So I played with Spark for another customer. I automated the installation of Spark, and it was a bit complicated with the Hadoop environment. So I had not a very good experience with Spark, and Dask is very light to start to play with on a laptop. So it was. I was confident that Dask was a solution for this project. We tested Dask. It worked fine. A bit difficult at the very beginning because it was a lot of tools to discover. I will explain that in the next slide. But at the end, it was a great journey, and now we are happy to use that. So maybe I can continue with the next slide.
That will be fantastic. And I'll just remind everyone who's tuning in now to let us know where you're from and where you are in your interest. And any questions, please put in the YouTube chat and we'll do our best to get to them during this conversation.
Okay. So this project was about transformation of healthcare data. For my client is a big pharma company, and for this project we managed a large amount of data, real-world data, data from hospital, data from insurance companies, and data from digital appliance. Yeah, you have the list of the different source of data here. And so it means large amount of data, terabytes of data, but also different sources. It means different format of data. And to play with this heterogeneous source of data, we needed to transform to a command model. And this command model actually is defined by a consortium, a group of people, the ODC consortium, and propose a common data model used by many companies all over the world. And you have an example here. So to be clear, these data are about patients. So here, person, and the visit when they visit their physician, and observation period, the device. So all data are related to a patient journey in the hospital or to the GP. Yeah.
And you may be getting there. What type of questions do you try to answer using this data, and who is it? Is it hospitals or pharmaceuticals, or who is doing this type of work?
Actually, hospital play with this common data model. As simple as the last example is about the COVID, to better understand who is impacted, when, etc. And for my clients, big pharma, to check actually the role of a medicine, and maybe to propose better medicine according to the age, the origin, the gender, and all this information. So there are, and for sure with this information you have to handle bias, maybe due to I don't know, for a special medicine, people will propose this medicine not for the good reason, but because it's reimbursed by I don't know, the NHS in UK, etc. So it's quite it's a large area, a lot of stuff to do. Yeah.
Great.
So, okay, my preferred slide. So not a lot of pictures, but actually at the beginning of the project. So as I said, we played with we had a Redshift. So it's a AWS solution, a data warehouse. The engineers are responsible for sizing the clustering, and the developer use SQL to do the transformation. It was difficult to manage to update the transformation with this solution. The SQL query was about several hundreds lines of code. Not simple to manage, and Redshift took time. You were not sure about the result. Will Redshift be able to provide to compute everything? So it was a bit confusing. And we also, so Redshift, you can load the data directly in Redshift. and we had to transform our source files in CSV format and unzip this file and load this file in Redshift. It was a bit cumbersome, and so we decided to play with Dask, and at the very beginning we played with a large virtual machine on AWS as well. So it worked, but at the moment, even the biggest machine on AWS wasn't able to run properly our workflow. So we played with Fargate and then with ECS. So the light version of Kubernetes, they are not Kubernetes, but orchestrate Docker containers. And why didn't we play with Kubernetes directly? Because the IT wasn't happy to start a journey on Kubernetes. IT was more confident to play with a managed service, managed AWS service, but at the end, Dask shined on the Kubernetes. So definitely, Kubernetes is our best, is the right orchestrator platform for us. So as I said, in the team we have data scientists and data engineers who are also DevOps. I'm part of the data engineer DevOps architect, and be able to play with only one language, Python. It's easier to communicate, and for data scientists to participate to the code transformation as well. And data scientists discovered Dask, and now they use Dask for other scenarios. So we definitely appreciate Dask, and it is now for this team a good solution.
Great. I have a non-technical question. It's essentially a cultural or organizational question. When you've mentioned 3 important stakeholders in terms of adopting technologies: data scientists, then DevOps, infrastructure engineers, for lack of a better term. I mean, we're seeing a lot of specialization in that space as well, and then IT. And I like your description of IT's response, which is one I've heard and seen many times before. But I'm wondering just your thoughts on how organizations make decisions when you have different sets of stakeholders such as these with different incentives and different priorities.
For sure, companies where IT are not confident using modern platforms like Kubernetes, because they don't have the resources yet, or train people to play with this modern platform. They are not confident and prefer managed services, simple solutions, but it doesn't help for innovation. And as far as I understand, the business want to run advanced, want to be able to run services on advanced tools because they want to innovate. So some companies, I worked with small companies, startups, and they understand they need the best technologies, and they are not afraid to hire the right people and play with the right tool. But it definitely depends on the environment, the legacy. So we have to convince people to play with modern tools, and it's not actually playing with Kubernetes. You don't need people full time to manage this platform. It is simple to manage this platform. They are resilient, so you don't need that much resources.
Great. All right.
Actually, it's my experience.
Transformation, the transformative time.
Yeah, so it's always files, data. So on the left, we have, as I said, CSV in JZip files. So first step was to transform. So at the very beginning, we played directly with CSV and JZip and JZip file, but the jobs were not fast, didn't work. So we had to migrate to a modern format, like when Parquet was the right solution. So definitely Parquet format is amazing. It's versatile. It works with different platform. It's really optimized. You can read, write quickly data from this file. You can extract only some columns. You can manage partition, compression, typing. So it's a huge step in advance compared to CSV format. So it was part of our journey, actually, discovering Dask and also discovering Parquet. Yeah. So files transform to let's say table, actually. Yeah, we can call it table, because actually our final files maybe are in Parquet format as well, but it's possible to access this data from at the AWS Athena, Redshift, Spark, because yeah, it's Parquet and it's versatile. So yeah. So the map transformation. So we have raw table. We transform to a common data model to get a table named person, for instance, visit detail, providers, and one table actually it's a couple of it may be 20, 30 terabytes of data. So for only one table, it takes time actually to run a transformation. So it means we have to, because as I said before, we can handle 30 tables. We have to run a transformation per table and do an orchestration for each table, because some tables depend to other tables. So we have one Dask execution per table, and to orchestrate each of these transformation. And Cubeflow was the platform we decided to use to orchestrate the transformation at the table level. Okay, let me show you this picture. So it's a screenshot of Cubeflow. So it's a platform developed by Google, IBM, AWS, and it's based on Kubernetes. And Cubeflow offers the Jupyter notebooks, pipeline, ML serving. So it's good it's a good platform for data scientists. And for the orchestration, it's based on the Argo, and so it works fine. And this is so this screenshot is a workflow of transformation from one table to another. So it's yes, tables are interconnected, and let you imagine that behind each box, one box is a Docker, is a container on Kubernetes. It's a pod, and behind one pod we have a Dask cluster, which triggers many workers. So it's a kind of two level of split, actually. We split the transformation per table, then Dask splits the transformation on many workers, and it works smoothly because both tools run on Kubernetes and share the same.
Can I ask you, Micheal, who in the organization needs to use Cubeflow? So my question is, do data scientists need to use Cubeflow and Argo, or is it the engineers for the most part?
Yeah, it's an important question. So the data scientists use Cubeflow for the Jupyter notebook. Mm-hmm. And from this Jupyter notebook, they run Dask as well to provide POCs. And And also they use a Cubeflow pipeline to run advanced pipeline once the pipeline is completely defined. We also use a Cubeflow pipeline from web application to run asynchronous jobs and jobs based on the data science tools. So it's a platform used for different projects with and we use so the main components of Cubeflow, and we also use Dask.
Great.
Okay, so let's go now to some tips and tricks. Actually, this one, it's actually I like coding in Python because Python is versatile. You can you can code with an object-oriented programming approach. You can run functional programming. You can run just some scripts. It's simple scripts. And here it's a mix of object-oriented programming and pandas execution. Pandas is like functional programming actually, because you pass a function to an array of the data frame. So, and here so transformation is quite simple. So you read data, you transform data, then you write data. This class inherits from a transformer mixin, and this transformer mixin is able to repartition input data. So, to information here. Repartitioning with Dask is very important. In this example, to create a visit detail table, we read data from the TT medical table, but we only need a few columns of this table. So we use a Parquet format, so it's easy to extract only a few columns because it's a columnar format. But because we extract only a few columns, the partitions of the original data doesn't make sense anymore. A good partition, it's about 100 megabytes. Yes, per partition, but because we extract only a few columns, the input data is not well partitioned. So it means you have small partition, many partitions, and your graph is not optimized. So here, first step is to apply a ratio to this repartition. So 30% here. So, and with a class definition by inheritance, we apply automatically this transformation. So the transformation here is simple. It's only a function, and we mask the typing as well, and the repartition. Yeah, and okay, so a bit extract from the documentation from that. So repartitioning is very important, and at the beginning we played with this parameter partition size because it is simple. You can decide to partition with a size of 1 gigabyte, but we discovered that the workflows was just before the repartition was executed twice because of this warning. So this warning is very important. As soon as you know you can anticipate your repartitioning, just apply a ratio instead of a size. But it comes with the experience of your data for sure. Okay. Okay. Another trick. Here I can share a Jupyter notebook about this one. Okay. Okay, so let me start a Dask cluster. Not sure for this example it's required, but it's always funny to show how it is simple to start a Dask cluster.
I love all the functionality in Jupyter Lab for it as well.
Yes, sure. Ah. Oops. Okay, anyway. Okay, so let's start here. I connect to the cluster. Sorry, the code is here. Anyway, so we have now Dask cluster. So in this example, we have a simple data frame. So here I display this data frame. So it's only one column data frame with A, B, C, D values, but with two partitions. So partitioning is very important. It offers distributed computing. So you can see that the index on the left is after reset index. Is not 0, 1, 2, 3, but 0, 1, 0, 1, because the reset index is done per partition. So starting from 0, for each partition. And if you want to build this this column of increment of 1, 2, 3, 4, 5 till the end, there's a, I don't remember if we found the solution or if we got the code from the internet, to be honest. Anyway, that's not the matter. So here we build this object, so a Dask data frame, chunks, named chunks, and each value represents the length of a partition. So this example, we have 2, 2, because first partition 2 rows, second partition 2 rows. That's fine. And we compute the sum of this these values, so 4 rows. And now we play with the Dask array to plug a new column with the index from 1, 2, 3, 4. So mixing Dask data frame with Dask array here was the solution to add this column with something optimized, actually, because it's not that simple to share this increment across all the partition. So yeah, but with 3 lines of code here now we have 1, 2, 3, 4. So imagine this transformation with terabytes of data. So it's quite useful. Okay, are you convinced, Hugo, about this? The 3 lines of code?
I'm sold already.
Thank you very much. Okay, back to the slides. Okay. Okay, let me show you maybe a more advanced transformation, just for the things to be clear. Oh, and I've got this one. Definitely, this one was found on the internet. Culling empty partitions. So when you filter data from your full data frame, sometimes one output partition is empty. So for some reasons, it's better to not have empty partition, and Dask at the time we use Dask, to be honest. I don't know with the latest version if it works smoothly, but we had to remove this partition. So this one removes the empty partition. So it's a bit, this one is a bit advanced, because here we play with a from delayed function to be applied to each partition. So the idea here is not to go deeper in this code, but just to there are sometimes some issues we faced, and we had to find a solution. What else? Okay, just by example. So here we have a data frame with A, B, C, C. And the first partition only A and B, and the second partition it's a CC. Okay, so two partitions here. And now we filter this data frame and remove the rows with a C value. And if we do that, we have only A, B. Okay, it's quite simple. But the number of partition is still 2. It means the second partition is empty. And with this function, call empty partitions, and we, for sure. Let me.
What happened?
Yeah, I didn't load the call partition, empty partition in memory, so now it's in memory. Okay, so now if I call the end partition to this object, we have only one partition. So yeah, a few lines of code, but maybe it may be useful. Another trick, and sometimes you don't have empty partitions, but tiny partitions at the beginning of your partitions, or at the end, or in the middle. And it happens after an interleave partitions are true. And to be honest, I don't remember why, because I've not played with this code for months. But anyway, I think you understand the interest of merging tiny partitions with their neighbors. So it's not a big change. It means we have a threshold of 100 rows, and when the partition is less than 100 rows, we merge it with its neighbor. And so there are special situations for the first partition. We merge it with anyway. So a bit of 10 lines of code as well, and it reduces the asymmetry of the size of partitions without running a repartition, because repartition may be consuming as well. Okay, and now a real transformation. So this is one of our table named person. So remember, it was it inherits from the transformer mixin, and here we list the input table. So we have two tables, and we select the columns, only the columns required for this transformation. And the main function is here, process. Mm-hmm. So it's a game of filtering, resetting index, playing with drop duplicates. We reset the index because when the data are indexed, it's mandatory if you want to play with map partitions. So map partitions is very useful because the Dask scheduler doesn't need to do some checks across the partitions. It's simple. It simply execute a function across each partition. So here the drop duplicates, and drop duplicates work because we know that we have indexed our data, and we will not we will drop duplicates for the same ID here. And we reset the index, and it's already sorted, so no need to sort again. The sorting algorithm, it's time consuming, so if you can avoid to sort, it's really better. So we several times played with map partitions, empty partitions. So I didn't lie, we use it, and repartition at the end to have a proper, correctly sized data frame. Okay, and this one person inherits from the table object, and person makes in and defines the types and the index. And we have also a few lines of code who are responsible for creating the Cubeflow graph, because we know for each table what are the input tables. So we can rebuild the full graph just by reading this information. And yeah.
Wonderful.
Thank you. Thank you.
Yeah, please go on.
Yeah, yes. And actually, how did we, as a developer, I'm not, I don't know the business of the map transformation. I don't know how to transform data. So one of my colleagues, specialist in healthcare data, draft some Python code for the transformation and run it with a few amounts of data. He wrote some PyTest as well. And as a data engineer, I was responsible for optimizing this code, for this code to run smoothly.
Yeah, that speaks to a greater question of mine, which is how, and it's something we mentioned before, but how data engineers and data scientists work together, and who does what and what the overlap is. Because we have some ideas, but I don't think the space has clarified itself completely. So there's a lot of things still up in the air, right?
Actually, for this company, I was the cloud architect as well. I proposed some tools like Cubeflow, Kubernetes. I did the job of optimizing the transformation. And yeah, the data scientist draft some line of codes and ask me for optimization. I don't know if it's good or not actually to have to do this optimization. Some companies are not able to hire data engineers. They just want data scientists to write some transformation and run smoothly. And sometimes I have the argument of but Dask, why didn't you use BigQuery tools in SQL? Because you don't need a data engineer to optimize your job. So maybe I think with a lower level of code, we are able to optimize the execution deeper than with a SQL system, but you have to mitigate between the time you spend to do the optimization and the time and the cost of running jobs in systems like BigQuery, where things run and you don't have a console to check or to optimize. And definitely Dask is the right solution, because as I said, now data scientists use Dask for other services. And it's close to their habits, because data scientists write code with Pandas, NumPy. So it's not a real question. If people are used to play with SQL, they will use BigQuery, Redshift, etc. Yeah. Oh, can't hear you. Oh, you're on mute, Hugo.
I was just saying, if people want to get more involved with this type of stuff, definitely check out the Dask documentation, check out Coiled, and check out Cubeflow as well. But Micheal, are there any other resources people could check out if they're interested in building these types of flows?
I think you listed the right the tool I played with. Yeah, definitely.
Cool.
Yeah.
Great. Well, I just want to thank everyone for joining, and thank you once again for your time here.
Thank you, Hugo.